So now we are at our final subject of the second MAC exam, and it's called constraint optimization. So I also like to start this one off with an example. Let's say you are back in FME, and you have 1 hour until the FME Expo. Now, your FME team sells bracelets, and specifically you sell two types. You sell really basic bracelets that you sell for a price of, let's say, $2. Let's say that's your contribution margin off of those. So assuming the variable costs are taken out of the price already. And these take, let's say, they take 5 minutes to make. So we'll call this your constraint. It's a limiting factor. Now the other type of bracelet you sell are these really gorgeous special bracelets right here. And these ones you can make a contribution margin of $3 off of, so you make more off of them because these cute beads are a little more expensive, but you also sell them for a lot more. However, your constraint is 30 minutes. It takes you an entire half an hour to intricately put these all on in the appropriate manner. So if you have 0 in stock right now and you need to make as much profit as you can at that FME Expo, which bracelet will you choose? The cheaper one, the one that gives you less contribution margin, or the one that gives you more contribution margin but takes a little longer to make? Remember, you only have 1 hour before the expo. So the right answer would be the smaller, cheaper one. And that's because, if you may have noticed, you make $2 in contribution margin for every 5 minutes, which is way larger than $3 every 30 minutes. In other words, yeah. Okay, so that is the basis of the constraint optimization. And constraint optimization is basically just these two graphs. And what we just did there was the first graph. So you want to start by listing out all your products. You can draw this graph out. So you have A, B, and C. Then you want to list the revenue per unit, which will be given. So A has 10, B has 8. The variable cost per unit, 7 and 3. And you'll have to figure out the contribution margin per unit. So A has $3 in contribution margin, and B has 5. So B may be looking better as of now. However, remember, we have to worry about constraints. So next you want to write out the constraint per unit. A takes 2 minutes to make, and B takes 5. So then you want to divide that the contribution margin divided by constraint. So 3 divided by 2 equals $1.5 in contribution margin per minute versus $1 per minute. So finally in this chart, you want to rank them. The one with the higher or the greater contribution margin per constraint is ranked 1, and then the second one is ranked 2. And if you have a third, it would be ranked 3. So because A gives you $1.5 per minute, you're going to rank it in first place. Now where we use that is in the second chart. So in this example, it was stated that your total constraint was 60 hours, or in other words, 3,600 minutes. And then they're not just going to tell you to, which one would you make, but they're going to give you a certain amount of demand. So they're going to say, okay, in realistic terms, the demand for A is 300 units. So people want to buy 300 units, but they will not buy over that amount. And the demand for B is 700 units. So in best case scenario, you can make 300 units of A and 700 of B. But because of our constraint of 3,600 minutes, that's not possible. So what we want to do first is we want to maximize our rank 1. So our rank 1 was A. So if we want to maximize it, we want to make as much of it as we possibly can. So we're going to make the full 300 units. So the answer for A, how many A we're going to make, is already 300 units. And I kind of wrote here at the side, if we make 300 A's and each A takes 2 minutes, then we're getting rid of 600 minutes, sorry. And then so we want to maximize rank 2, but because we only have 2 ranks in this scenario, we're going to ignore this. That's only applicable if you have 3 products. And then you're going to look at what is the amount of constraint left. So if we take our total constraint minus the constraint used for rank 1, so that 3,600 minutes minus the 600 minutes it took to make all of the A's, then that tells us that we have 3,000 minutes left to make as many B's as possible. So then we want to go to our last stop, number of units our constraint can make. If we have 3,000 minutes left and it takes 5 minutes to make each B, then 3,000 divided by 5 means we can make 600 units of B. So that is the amount of B we can make, and that is our answer. So again, we can make 300 units of A, and with the remaining amount of time we have left, we can make 600 units of B. Okay, perfect. Now let's practice a quick problem.